Hello, I am Jesse, and this is going to be day one of teaching myself how to do some circuits. I've always been interested, so I'm excited to learn more about some electronics. It's called The Art of Electronics. I'm on page 6 here, and I've learned about some resistance and some voltage and some current, and I got my breadboard set up. And so today I'm going to be implementing my very own voltage divider. It is some high-tech stuff, I know, but hopefully if I keep doing this day after day, I might be able to learn a bit more about some electronics. So I'm excited, and I'll show you guys a little time lapse of what I'm doing here. So here is the example that the textbook gave us. It's written a little weird, so I'm going to do my best to explain it really quick. What we have here is a simple circuit with our Vin being applied to two resistors that are being wired in series. The first resistor is labeled R1, the second resistor is labeled R2, and we want to find the V out, which is going to be the voltage across that second resistor. And that is going to be our predictable voltage in percentage. And so we can find that given this equation right here. So V out is going to be equal to V in, the input voltage, multiplied by R2 over R1 plus R2. So this is just telling us that we want to find the ratio between R2 over the total sum of the resistances multiplied by the input voltage. And that will give us the voltage over R2. So I've drawn out a simple example to hopefully make this easier to understand. So here we have a very simple voltage divider. The input voltage is going to be 100 volts, and we have two resistors wired in series. The first resistor is a 99 ohm resistor, and the second one is a 1 ohm resistor. And we want to get the voltage across the second resistor. So we can easily calculate it out. The V out, the voltage across this resistor, is going to be equal to V in times R2 over R1 plus R2. Remember, this is R1, that's R2. So all we're doing is finding the ratio of R2 compared to the total resistances. So that's going to be 1 over 100 times 100. The voltage over R2 is just going to be 1 volt. And because of Kirchhoff's voltage law, the sum of all voltages in a closed loop equals 0, and the voltage drops equals the input voltage. So this is going to make finding the voltage across the first resistor very easy. It's just going to be 1 minus 100, which is going to be 99. So I'm going to go build a very simple example quickly, and we're going to measure the voltages and see if I get my predicted output. Alright, here's what we got going. We can see my beautiful power supply on the breadboard. We got two 1 kilo ohm resistors wired in series. And then we have this gray wire that is hooked up to the positive end, and this brown wire hooked up to the negative end or ground. So if I measure this voltage right here, this is gonna be our V out, the divided voltage right here that we wanna measure. And I calculated it a bit right up here. So we have the 5 volt power supply with my two 1 kilo ohm resistors wired in series. V out should equal to about 2.5 volts, and that should be 2.5 across the both of them. Let's put this guy right up there. That is going to be my ground terminal. Let's see if I can prop this up really quick. There we go. Let's measure right across here. And we can see we are getting about 2 volts, 2.1. So there is going to be a bit of 2.2, there we go. There's going to be a bit of voltage drop across these resistors. So we're not going to get exactly 2.5. That's just kind of our estimate. Alright, thank you guys all for watching. If you are watching, that's pretty chill. I'm doing this series mainly just to teach myself and make it a little fun. I've always wanted to post YouTube videos, you know.
I like talking, I like filming, I like doing hands-on stuff, and I like learning new things, and I think this stuff is pretty cool. So hopefully if I continue with this, I'll be able to learn a bit more about circuits. All right, peace.